Hello everyone, and welcome. Today we're going to learn the C programming language. So the stream yesterday, I accidentally left the stream open for 9 straight hours while I went to sleep. So I decided to delete that VOD and redo the whole thing so we can have a clean recording. Today we're going to start with the introduction to C programming language. So we did Python. We did our first project with Python, which was the reverse shell, which is already on GitHub. Programming fundamentals, yes. So github.com/darkarp/programming-fundamentals. This is our finished reverse shell. Now we're going to start with the C programming language. So learning C programming language and doing the same project as we did with Python, with the reverse shell, and learning a bit about computer architecture and later on how it translates into assembly language. So the first thing is the setup, the compiler and the whole environment setup so you can code in C. C is a very different language from Python. In Python, Python is an interpreted language, as we covered in the beginning of the series, while C is a compiled language. And a compiled language, you need a compiler to transform the code that you write into some data that will then be part of a binary file that you can execute. So let's do that. So the Gcc compiler, which is the one we're going to use for C, is usually already installed in pretty much all the Linux distributions. But we're going to see how we could do it on Linux as well. Right now we're going to do it on Windows. So you'll notice if I go into PowerShell and I type GCC, nothing happens because I don't have GCC. So we're going to download GCC Windows. I'm just going to search for GCC Windows, and we'll find here installing binaries, blah, blah. And you will see a bunch of options. And you'll see Microsoft Windows, so you see the Cygwin project and the MinGW project. We want the MinGW W64, the 64-bit version. And when we go there, we go to Downloads, and now you can choose some different options. I'm just going to go with the LLVM one. So I click on the GitHub link for it, and it brings me to the release. You can check out the whole page here if you want. And all we need is to go into Assets, MSVCRT, x86-64, perfect. This is ours. And if you're on a Windows machine, 64-bit, this will be yours too. So after you download it, this will come in a folder where you have all of these subfolders. All of these folders, I'm just going to extract them into our C disk, and I'm going to call it LLVM-MinGW. I'm going to extract them all in there. And we're going to see what they contain in a bit, at least what one of them contains. Okay, so when we go into our C drive, LLVM-MinGW, you'll see we have this, so these are DLLs and object files for a bunch of different platforms. What we're interested in is this bin folder right in the beginning, which has a bunch of executables. Among them, we have GCC and G++ for C++. We're interested in GCC, which is our C compiler. Now, to make this available, we have to go into this bin directory, copy this path, and edit our environment variables to include this path so that when we type GCC in the terminal, it can find the executable. So we're going to right-click on this PC properties. That's a quick way to get to where we want to. You're going to search for advanced system settings, and this shows up. You're going to go to environment variables here. Now we have the user variables and the system variables. We want to change the user variable path, so you double click, and you'll see a bunch of different paths in here. And what this does is basically, so you click new, you paste your path, and you click OK, and you're done. So what this does, so when you go into PowerShell and you type something like GCC, now I haven't pressed OK, so it hasn't done the changes yet, but it's going to first figure out, well, is GCC something that is in the directory I am right now, right? If it isn't, is it something that it's in the environment variables? And it's going to check the path environment variable, of course. Is it in path? And it's going to check every single one of these directories and check if GCC matches anything that is in here. And in this case, it matches what's in this bin directory. So that's why we're putting this here. So we can type GCC in terminal and have it show up. Now, if we type it again, I notice that it still didn't work because the environment variables need to be reloaded. So you have to start a new window, new command line. And now if you type GCC, there we go. We get a CLang 14 error, no input files, because we just put the command, right? We can do -v for the version, and we have some details about this. Okay, our GCC compiler is done. So let's look into how we can code and compile programs in C by making our first Hello World program. So we can use Visual Studio Code as we've been using for Python. This was the server, the last thing we did. I'm going to open a new here. I'm going to call it C. Yeah, and I'm going to call it. I'm going to create a new file called helloworld.c. So in Python, the files end with the extension .py. In C, they end with .c. As soon as I save this document, VS Code asks me if I want to install the recommended extensions for C. You do want to install them. But if this doesn't appear, you can just go into extensions and type C, and you'll find right in the beginning that these are the first one, not this one, this one. 27.9 million downloads, the C, C++. So I can just install it here instead of clicking there. It's the same extension. And you want this. This is so that you can have the IntelliSense, the whole profile for the different colors, the errors and whatnot. So you want that extension. Okay, so now that it's installed, let's do our Hello World program. So I'm going to start writing a Hello World program, and I'm going to explain it later what it does. I mean, we know what it does, but I'm going to explain why we use what we use. So there you go. This is a Hello World. Let's change this font size. Let's change it to 18 or something. Yeah, I think that's what I did on stream too. Okay. So how do we compile this? So we will explain this in a bit, but to compile it, well, first you have to go into your terminal. So you can click here in this little rectangle to show your problems, the output, blah, blah, and your terminal. And when you open the terminal, it opens in the directory that you opened your VS Code in. But if not, just navigate to the correct directory so that you have the hello world.c in this directory. And you're going to do gcc hello world.c. That's it. That's all you do. And now you notice that there's a new file called a.exe, which is an executable file. If we run this file, we'll get our hello world. Awesome, right? Now, you can have you can supply different options to GCC. So you can you supply the .c program you wish to compile, the source code file, and you can supply additional flags like output, so that you can do hello world.exe as the output, and now it will output as hello world.exe instead of a.exe, which is the default. And there are other flags we will learn as we code in C, but for now, this is all you need to know. Okay. So that's how we compile, and that's how we run things in C. Awesome. Now, here, let's try to explain what's happening. So I'm going to make a lot of references to Python since we learned about Python in the beginning of this course. But I'm also going to try to say things in a way that you'll understand even if you didn't know Python. But in Python, you would use import to the word import, or the word from something import, to import modules and libraries into your code. In C, these libraries are called headers, and you will use the hash include to import them. And the name of the file, the library in question, the header in question that you're going to import, is inside these straight brackets, these less than and greater than signs. In this case, we're importing a library, or a header file called stdio, which stands for standard input and output, and the H for header. Pretty much everything will end in .h when you're doing includes. And this is for the functions that handle the standard input and output. One of which is this printf function. So to use this printf function, I need to import this from the standard library. Oh wait, I was actually also wrong. There's something else that is installed, which is the extension pack. So if it asks you to install the extension pack, just click yes. Otherwise, C extension pack is also something you want, and it's right there. So it's easy to find. Just type C extension, and you can also download that one. Okay. But yeah. Now, a big difference is how we declare functions in C. And we're going to go deeper into this, but I just want to explain what code you see on the screen, just so you have an idea. So the int before the word main, this function is called main, and int is the return type. Int stands for integer, same as in Python. So we specify the return type of the function as we declare the function. And notice that at the end this does a return 0, which is an integer, right? And all it does is really the printf, which prints hello world into the screen. And F stands for formatted, because you can insert specific tags, expressions in here to allow the interpolation of variables. But we'll see all of that later on. One big thing about C that we need to understand is that it's statically typed, unlike Python. So in Python, you can declare functions, declare like arguments that don't have a type, while nothing in Python really is declared with a particular type. Right? You just say a equals 4. A is an integer, but we, don't really specify it. But A can also be equal to something that, like the user inputs, and that can be a number, that can be a string, whatever it is. You can treat that A as any different kind of type, because in Python, types are not enforced at compile time. There is no compilation, but basically when you're running the program, it doesn't ask you to specify every single type of everything that you use. In C, you have to specify every variable's type and every function return type. Everything which has a type needs to be specified with its type. And this has advantages and disadvantages too. But yeah, we will explain those in a bit. Note that if we do remove the int from here and we do void is basically what you'd use to denote null. It's kind of like a null expression, so it doesn't return anything, but that's what void means here. And also void in here to say that it doesn't accept arguments. But you can remove it, but it's standard procedure to keep it in. But if you do try to compile this, it will give you an error, because it will tell us the return type of main is not int. Okay, that's the first error. It's not an error, it's a warning, and we'll look at that later. And then here, void function main should not return a value, because we are saying that it's a void function, so it doesn't return a value. So if we don't return a value, what happens? let's delete this hello world.exe so we know if it compiles or not. It compiled, but there's a warning, which says the return type of main is not int. And that's because the return type of the function main needs to be an integer. The function main is a special function, okay? In Python, the execution starts from the beginning, from the very first line that you write. In C, the execution starts with the main function. So there needs to always be a main function. If you don't have a main function, this will give you an error and will not compile. You need a main function to start the program. And this function needs to return something, because this return will also be your the exit code of the function, and it's going to be used to know whether the program exited successfully or not. But again, we'll look into these aspects later. But just wanted you to get a nice overview. Let's go and install one more extension to make this whole process simpler. Because sometimes you don't want to just have to GCC, repeat this whole command again and again to just compile things. And sometimes maybe you forgot to compile and you ran the program as it was, and you noticed that there was an issue and you're not understanding where it is because you forgot to recompile. Well, there's an extension called Code Runner, which is, right here, Code Runner, 11.2 million downloads. Just download that extension. That will give you a little play button on the top right corner. And if you are in edit mode, like if you're editing this file and you click on this play, it will try to run the code. And it will call GCC by default. You can change what the compiler it is, but it calls GCC and compiles your program and then gives you the output in this output tab. And then tells you it exited with code. So here's your exit code. The exit code is this return type, this return value, and the time it took. So if you change this to 10, for example, and notice this is like, a purple, everything went well. It's a convention that if it returns 0, then it exited successfully. If it returns non-zero, it did not exit successfully. So now if I do the play again, hello world shows up again, but now it says exited with code 10. It's in red because it's the convention that if it's not 0, then this was some sort of error. So yeah, this is pretty neat. Yeah, that's pretty much it. Note that you cannot do, so if you're taking user input from the command line, you cannot use this Code Runner play button, because this output window does not, as far as I'm aware, does not accept user input, does not accept user interaction. So if you try to test your program here, it will just hang while waiting for user input that never comes. So in that case, you'd have to normally do the compilation process. But this is the setup for Windows and the Hello World.